Joan took a trip from Hamilton to Montreal, a distance of 830 kilometers. Sorry, did I miss it? Okay. Did I miss 3? Oh boy, let me go. Okay. She traveled part of the way by bus and the rest of the way by plane. The bus averaged 40 kilometers per hour, and the plane 500 kilometers per hour. Planes travel fast. The whole trip took 3.5 hours. How many hours did she spend traveling by bus? Is the question. Only by bus. Not really worried about how much by time, really. Okay. So I see. I don't know. When I look at these distance time questions, okay, like the last one where I had money and like the amount, I had two different equations. You're gonna have two different equations like all your linear systems, except if I start seeing them talk about time, that's gonna be one of them. A time equation. We can write our let statements too, right? You could say let x represent time on bus, and let y represent time on plane. Okay? So I like to have when I see these distance time questions, I like to have a time equation, especially if it tells me how long the trip took. And remember, there's a common theme. If you can come up with one of the equations as being very basic and like right off the top, then you could say right away as a time equation, you could have how long did the entire trip take? 3.5 hours, right? She only used two modes of transportation, so that must mean that when I add the times together, that has to be 3.5. Okay. The second one kind of stems out of a distance equation. Okay, so what you're going to do, remember, each of these represent time, right? X and Y is time. Do you guys do science yet? No. This is only your second class, eh? Eh? Oh, okay. Do you remember seeing the distance, speed, time triangle? Yeah, something like that. They use different variables for different things, right? But basically, speed, we'll use the word velocity because that's what speed is. Velocity is always the distance divided by the time. If you're driving in your car, you have like kilometers per hour. That's speed, right? While kilometers is distance, time is in hours. Okay, so you get this little triangle here. Okay. So my question is, I want to come up with a distance equation, right? An equation that represents the distance traveled by each of these modes of transportation. Well, if I were to cover up the distance in the triangle, how would you get distance? Distance would equal what? For those of you that have done science. Velocity times time. Okay, so I'm trying to come up with an equation that represents distance, right? It told me what the total distance was, didn't it? 830 kilometers. Right, so over here on the right, let's give myself a little space. 830, I know the total distance has to be 830 kilometers, right? Then I've just said using my triangle, d equals v times t. If I'm trying to create an equation to represent distance, because this is in kilometers, I have to do the velocity times the time. Well, I said x and y represented the time. So I'm going to have something that looks like this. X plus y But in the question, it also told me something about their speeds on each mode of transportation, right? So on the bus averaged 40 kilometers per hour. Well, there's my speed. The variable represented the time. So all I have to do is do 40 times that, because this is the speed, velocity, and the time. Together, when you multiply them together, you get distance. You get distance by the bus, right? And then the second one, same thing. Y represents the time on the plane. Well, the plane was traveling 500 kilometers an hour. So you're just going to slot the 500 in here, right? And then your end product is just the distance on the bus plus the distance on the plane has to equal the total distance. Very good. A little bit tricky. If you haven't taken science, yeah, it's a hard question. But if you memorize this triangle, right? And really, like, I actually don't even have the triangle memorized. I can't remember it. What I know is I always fall back to, like, if I'm driving in my car, I know my speed, V, is always something kilometers per hour. I know I have to divide them. So that's how I know in the triangle, distance goes on top, time goes on the bottom. Okay? I don't really memorize a triangle. Just know my speed. Okay? These are just two equations that you can solve now. How would you like to solve them? Substitution or elimination? Which one? Okay. All right.
I just have one question about the triangle.
Yes.
How would you find T?
T, if you covered up T,
wouldn't it just be like T equals D over V?
D over V, yeah. If you cover this up, it's D over V. Okay, I'll do my best to give you a question that looks like this one. We'll see the different styles on here, okay? I like giving this as kind of a general rule. Can you come up with a time equation? Can you come up with a distance equation? Okay, it's not always the case, but I'll try my best to give you ones that look like that, okay? You can see a theme starting to recur here, right? Like, this looks very similar to the mixture question, right? Looks very similar to the number of coins in a vending machine question, right? You're just adding two things together. It got to give you a sum, and then you're putting a decimal thing on there, right, to give you something else. This is kind of nice. If you can come up with an equation that looks like this one, the second one is kind of a product of that one, most of the time. Okay? We okay? So we wanted to do substitution. So what are we going to have to do? Am I gonna isolate for variable in this equation? No chance. You could. I don't want to. Why can't you just, in the top equation, we can say x is equal to 3.5 minus y. That seems a lot easier than trying to get a variable out of these guys. Right? So now I know what x is. It's this piece. Right? It's going to go right in here. For x, it's substitution. I'm going to substitute 3.5 minus y in for x because that is x. Right? So let's do that. It's 40 times 3.5 minus y, okay, plus 500y is equal to 830. Then we can just do the math. There's no more x's, right? Now I'm free to solve for y. You okay? Okay, Paul, yeah? Huh? Okay. Okay. I gotta get rid of the jail bars, right? Multiply in. So 40 times 3.5 is gonna be 140 minus 40y plus 500y is equal to 830. Okay? I see some like terms here. I see the y's here. I can collect those, and I'm going to take the 140, I'm going to move it to the other side. Okay, I'm going to subtract. Don't add, because then you get the wrong answer, right? So you get negative 140 plus 500. 460y is equal to 830 minus 140. Okay? So now we're going to go, okay, just got to do 690 divided by 460 equals y. Which equals 1.5. What does that represent? What does y represent in this? What did we say it represented? Yeah, Coco. Okay, good. It represents the time on the plane. So that's good. But what did this question specifically ask us for? Time on the bus. So we haven't answered your question yet. We know how to, though, because I have an equation over here that tells me how long she spent on the bus, or they spent on the bus, right? So x is equal to 3.5 minus 1.5. X equals 2. Everybody okay? Okay, so again, like you try to follow this format of trying to find a time equation, a distance equation with these particular questions, it'll be okay. And you don't necessarily need the triangle, but it's there to help you in case I ask something else or whatever. There's probably questions in the homework questions that are asked for something else, then you'd have to use the equation, okay, or the triangle. Is everybody okay? Everybody got that down? We'll try next one. I'll solve this one. I'll do the same thing as the last lesson. We'll solve this one, and then I'll set the third one up, and then I'll let you guys work till lunch, okay? Give you lots of time. I can bounce around and help everybody, okay? Okay, so let me get rid of this too. Okay, so Dora drove 50 kilometers per hour from Orangeville to Lemonville. From Lemonville to Honeyland, he drove at 80 kilometers per hour. The whole trip was 500 kilometers and took 8 hours. How far is Lemonville to Honeyland? Okay, I'm going to give you guys a sec. Okay, try to do this one on your own for a second. Okay, and use the first one as an example. Okay, I don't think it's much different. Okay, just take a couple minutes, see what equations you can come up with, and then we'll confirm them. But use the first one. It's very similar. And I would do the same thing. I'd set up two equations, one for time and one for distance, right? Time, you know what time is, so it took 8 hours to go well, right? So I'd say let x represent the amount of time traveling at 50 kilometers per hour, right? I'd say let y represent the amount of time traveling at the higher speed, 80 kilometers per hour. Sure, yeah. You can even brackets afterward, just specify which one of the speed. Okay, once you have those two things, then you can go, okay, well, the total trip took 8 hours. So if I add the time traveling at 50 kilometers per hour, the time traveling at 80, they better equal 8. X plus y equals 8. Should be 1. And then you can do the second one with the speeds. Okay, something along these lines. Okay, and then I said, okay, well, x plus y has to equal 8. Right? That would be what you would call the time equation. Then your distance equation would just be the two speeds, right? Hey. Oh, yeah. You need should grab a rock out front, bring it in. Okay. The second one, we're going to say, okay, well, 50 times, which is the speed, times the time at which I traveled at that speed, plus the 80 kilometers an hour, the speed times the time at which I traveled at that speed, has to equal 550. Okay. And this is what we're labeling our distance equation. Okay. You guys can do whatever you want at this point. You could do the two equations are lined up kind of nice, right? Like x's are kind of lined up with x's. You could line up y's with y's and a number with a number. You could do that and eliminate. You could do substitution. You kind of get the best of both here, right? You could do whatever you want. It doesn't matter to me. It's whatever's going to be easier. So if I wanted to get rid of x, for instance, I could multiply the first one by 50. Right? Then I'd get a 50 there, and if I subtract them, then the x's would cancel. If I wanted to get rid of the y, I could multiply the equation on the top by 80. Then I'd get an 80 in front of y, and then these would cancel. Or tell me x is equal to 8 minus y and substitute that into the other equation. You can do whatever you want. Okay, they're all going to give you the same answer. It doesn't matter. Okay, you guys try it, and then I'll do the work. Okay, and then we'll confirm whether you're right or wrong. Okay, this gives you a little practice, and I can kind of bounce around from here.